They give you another example on the standard deviation. So for the standard deviation, what did we do, guys? We found the mean. We took each value and we subtracted for the value from the mean to see how much deviation is there from the mean. Then we square each value. Then we added up all those squares. We got 24. Then we divided by the sample size -1. I have 5 values and -1 is 4. We got 6. And then we took the square root of 6. Now, all of this, guys, is summarized in this formula. Watch. Although you won't need to use the formula, but you're going to come across it when you do your homework. Even when you do help me solve this, the system is going to make you, just work on the formula. However, guys, you don't have to. You just can go to your calculator and find the standard deviation. But the system, and the way things work out, just inside my MATLAB, most of the time, the help will be in the format that you have to do your work by hand, but you don't have to. You just can use your calculator. So just to explain, this formula, S, guys, stands for standard deviation from the sample. It's called the sample standard deviation. What does that mean? X minus X bar means what we did here, guys, when we subtract its value from the mean, right here. 6 minus 5, 8 minus 5, 3 minus 5, 2 minus 5, 6 minus. So this is what X minus X bar means. Then we square each one. This is why the square, we have the square, guys. You see, we subtract it and then we square. Then you see this notation, which I talked about last week, which is called summation notation, means addition. And this is what we did here, guys. We added. Then we divided by n minus 1. N minus 1, which is the 5 minus 1, which is the 4. Look, this is the formula. And then finally, we did the square root, and that's what I did here. So this is what we call the sample standard deviation. And this is the formula that is built into your calculator, guys, to compute the standard deviation. As I told you, you don't have to worry too much about it, but I thought that it will be important to explain to you, just how the formula works. And this is how it works. And this is the formula in simples. This sign here is called the square root. This symbol right here, it's called the summation notation. X bar means the sample mean, the mean from the sample, which is 5 when we did. The X refers to each of the values, 6, 8, 3, 2, 6. One time X is 6, you do 6 minus 5, which is 1. One time X is 8, you do 8 minus 5, which is 3, and so on and so forth. And N, guys, is the sample size, which is sample size minus 1.
Is this how our questions will be presented to us?
Oh, no, your question will be just find the standard deviation. So you just put the data into the calculator and find it. You don't need to do the work by hand. But I'm just trying to explain to you, just what the formula looks like in the background, which you really don't need to deal with it. I mean, it's up to you. You can do the work by hand, but there is no need if you have this. Or static crunch, which I'm going to show you in a little bit. I'm going to go to the homework online and show you how to use the static crunch to find the standard deviation as well. So this is the standard deviation from the sample. If you have a sample, guys, this is the formula for the standard deviation. Now you see something here that's called S squared. Well, S squared, guys, means this S and then you square it. When you square, guys, something that has a square root, the square root will go away. So you're going to notice that this formula is exactly the same as that one, but without the square root. This S squared is called the variance. Sample variance. So if he asks you to find the sample variance, guys, you use your calculator to find S and then you square the number. Let's say S turns out to be 4. You just square the 4 and you get 16. So I will give you an example of this in a little bit as well. I'm not going to do anything anymore, guys, other than just enforce what we learned today. Let me show you the other two formulas that I put there by hand. Now, if he asks you to find the population standard deviation, the population standard deviation used the same formula as the sample standard deviation, but as you notice, guys, instead of dividing by n minus 1, we divide by n. Now, how do you know whether you need to find the population standard deviation or the sample standard deviation? It will say, if he gives you a sample, guys, and most of the time it is a sample, 99% of the time it is a sample, then you will find S. But if he gives you a data set and he tells you this is the population, then you find sigma. And S and sigma are already done on the calculator. I did show you only S, but I didn't show you sigma, which I'm going to show you in a second. So this is called the population standard deviation. And if you square sigma, guys, you will get the population variance. So this is called the population standard deviation. And this is the population variance right here. Again, if you ask me what's the difference, guys, the difference is if you have a sample, we label it as S. If we have a population, we label it as sigma. Most of the time we work with S, we work with samples, so it's very likely you'll be finding S most of the time. And the calculator is programmed to find both of them, and you just only select, the correct answer, whether it is S. This is called sigma, guys. This is a Greek letter. It's called sigma. Sigma stands for population standard deviation, and S stands for sample standard deviation. And I put the definition right here, guys.
In the sigma one, can I just ask, in the parentheses, is that a U or a W?
Where?
In the parentheses, like above, in the sigma,
Oh, this is the mean.
in the mean, yeah.
No,
Is
it's
that
just exactly like X bar. You see the X bar right here, which is the mean of the sample. This is the mean of the population. It's the same work. You will just do exact same work as I did right here to find the mean. Add up the quantity and divide by 5. But they just give them different names depending where they come from. If they come from a sample, we call the mean X bar. And if it comes from population, we call it a mu. Just like again, guys, I want to stress again, don't worry too much about the formulas. You will not be using those actual formulas. But I don't want you also to go blind when you go online and see them in the help me solve this and have no clue what they are. But you don't need to use them. You can use your calculator, which we're going to do this together, guys, using the calculator to do this example right here. Calculate S square and S for class 1 scores. What are class 1 scores, guys? They are 50, 60, 70, 80, 90, 100. Okay. Before I do it, guys, do you think the standard deviation is going to be large or small? Do you think are the scores widely spread all over the place? What do you think? We have some students who score. Do you think the scores are far apart, just from each other and from the mean? Would you say that? Yes or no? Yeah, I would think so. They're not consistent, guys. They're not very consistent. So you're going to get a large standard deviation. And let's put the calculator into practice and find this standard deviation. I'm going to use the older calculator to do this together. Okay. So if you have your calculator ready, let's do it, and then I'll show you how to do this step by step. Here's the calculator. You go to Stat, press Edit, and enter the data. And I'm gonna put 50, 60, 70, 80, 90, 100. Anyone want to give me a guess? What do you think the standard deviation is going to be? Just a guess. Just give me a number. What do you
50.
guys think? Can't be too low. It's not going to be low because there's not consistency in the scores.
50?
50 probably it's too much. But it's going to be large. You will see. Ready? Click on stat. Calc. And enter. And then enter again. Here you go, S. You can read it right here. 18.7. This is the standard deviation. That's quite large, guys. Almost 20 points out of 100. That's the largest standard deviation. And you should not be surprised, guys. It is large because we know the scores are, some of them are D, some of them are E, some of them are C, some of them are B. And the last two scores, 90 and 100, are A. So I'm not surprised that I got a larger standard deviation. Now, I like you to notice, guys, that there is another standard deviation value that's given after S, which is sigma. That's what I've been telling you about, which is 17.07. But if I ask you guys to find the standard deviation of this data set that I give you, it should be S because the data set came from a sample. If he told me originally that the data set is the population itself, then I would have chosen sigma to be the answer. But he says this is a sample, then I would use S. And the first value, guys, is the mean, 75. So if you take those values, add them up, and divide by 1, 2, 3, 4, 5, 6, you should get 75 exactly. That is the mean. So S will be, let me write down the answer from the calculator, 18.7. Okay. He wants S squared, guys. Can you help me find S squared? What do I do to find S squared, which is the variance? What did I say earlier to do to find S squared? Yes? If you have a number, guys, how do you find its square?
You have to
Just multiply by itself. Just use calculator doesn't do S square, so you just have to do the math. Clear? And just do the math. 18.7 times 18.7. There you go. I got 349.69. All right, so that's how you find S. And so when you do your work online, if he asks you to find the variance, guys, use your calculator, find S, and then square the answer. You will get, just the variance, which is called the variance. But if he asks you to find the standard deviation, it's straightforward of the calculator. Now I have one question for you. If your data is in dollars, I have $7, $3, $8, $5. I want to find the standard deviation. Let's find it. I'm going to do it. And then I'll ask you the question. Here you go. So go turn the calculator on. I'm going to go to stat, edit, L1. I'm going to clear it and put those values. Look how easy it is with the calculator. 7, 3, 8, 5. Any guess? What do you think the standard deviation is going to be? Give me a guess. The average, let me tell you what the average is. 7 plus 3, 10, plus 8, 18, plus 5, 23. And if you divide it by 4, it's going to be about $5.60. So what do you think the standard deviation is going to be around how much? The mean is $5.60. And those are the values. What do you think the average deviation will be?
half that?
Probably 2. Okay, let's say you said 2, you say 3. Let's say you guessed about 3. Let's say half that, yeah, 2.80. Let's check. Okay. Well, we don't need, just to wait long. Stat, Carl, probably you're right. Enter. Ready? Okay, it was 2.22. What do you guys think that the unit is? The actual values are in dollars. The mean is in dollars. The standard deviation is how much each value deviated from the mean. So what do you think the unit is going to be here? Yes?
Dollars.
Dollars. Exactly. So what I'm trying to tell you guys that the standard deviation takes the same unit as the original data set. Now my question to you is this. What do you think the unit of S squared is going to be? Let's find S squared. 2.22 times 2.22. I got 4.93. Who can tell me what the unit is going to be? That should be easy, guys. If S is in dollar sign, what would S squared be?
Dollars.
I don't agree with that. If a unit is in dollars, when you square it, it will be what? Dollar squared. And dollar squared, guys, doesn't make a lot of sense to us. We don't, what I'm going to do with the unit that is in dollar squared? Yeah, in dollars, yes. $5 plus $7 is $12. So dollar squared, it's not much use for us. That's why, guys, we refrain from using the variance, but we use the standard deviation most of the time. So the reason, if somebody asks you why would you use the standard deviation and not the variance, you tell them the standard deviation takes the same unit as the data set, whereas the variance takes the square of the unit. And sometimes the square of the unit has no meaning. What's a dollar square? What does it mean? Has no meaning. So we're better off using standard deviation than using variance. And for this reason as well. Okay. Here is one question for you guys. And please, I want you to do the work. Just don't wait for me to find the answers. Because once you do the work and understand it, you're all set, with this section 2.4. You are a basketball coach and you want to hire a new player. You want to add a player, just to your team. So you interview two players. Player one and player two. But before you interviewed them, you checked their playing records, their scoring records. So you looked at the last 6 games of player one and how many points this player scored, and you got the following: 19 points, 21 points, 22 points, 28 points, 18 points, 21 points. That's a player one. Then you looked at the records of player two: 9 points, 40 points, 35 points, 8, 15, and 20. Here's my question to you guys. You want to bring someone into your team. You want to put that person, just on the floor and guarantee a certain number of points on each game. So on average, you would want this person to score an X number of points, and you want to make sure that you get it. So you want this person to be consistent. Consistency is the name of the game. Which player would you hire, and tell me why? Would you hire player one or player two?
Player one, because they consistently score an average amount.
Okay, and I got another student who said player one. Let's see what other students are saying here. Player one, I agree with you. But you guys, you need to justify the reason. I kind of feel you feel that player one is more consistent, but feeling it is not enough. What would you compute, guys, to ensure that player one is more consistent than player two? What do we find? There's a number that you have to find in order to convince, just the coach, just to make the right decision. Let's say the coach doesn't know any statistics and you need to help him out. What would you calculate for him?
We add the numbers.
Not add him. We find what did we call this magic number in section 4? Standard deviation. We will help the coach by finding the standard deviation of each player. And as you said, one of you said that I would hire player one because the scores are consistent. Well, you're going to notice that the standard deviation for player one is a lot smaller than the standard deviation of player two. So I know you have a feel, guys, that player one would be more consistent, but your feeling is not enough. You have to support that. Supporting that is to find the standard deviation of each player. Let's find the standard deviation of each player, guys, and see, and let's confirm that player one is the one that we're going to select. Okay, let's do it. There we go. Put it there. Just you're going to see the power of standard deviation now. Okay, so I'm going to go to stat, edit. I'm going to clear L1. And I'm going to put the players here, 21. Any guess? Someone can guess what the standard deviation is going to be for player one. Just give me a guess before I hit, just the answer. What do you think it's going to be? It's not going to be large, definitely. Just
Like
give me a guess.
3 or 4.
3 or 4. Anyone want to say more than 3, less than 3? Okay, let's see. Stat. I'm curious myself. I just made up the data, so I don't know what is it going to be. Just hit calculate. Well, good guess, guys. You said 3 or 4. It's right between 3 and 4. We look at S. We don't look at sigma because these are samples, guys. So your S is 3.5. Excellent. So S1 is 3.5. Okay, now I want the students to guess what do you think player 2 is going to be. You all agree it's going to be more. So how much more? What do you guys think? Okay, in the chat. Oh, probably even more, a little bit more than 5 or 6. I have a student who said 5 or 6. Let's check. Probably a lot more. Okay, so I'm going to clear, stat, edit, L1, clear. There you go. And watch, guys. Player 2. I hope that by the end of this lesson you appreciate learning the standard deviation because it has a lot of application in real life. So 9, 40. I suspect it's going to be more than 6. I mean, player 2, if he has a good day, he might score 40 points. But if he has a bad day, he might score 8 points. So you're taking a risk, just with this one. Okay. We got the student say 13.5. So let's see. Stat, calc, one variable statistic, calculate. There you go, 13.5. And you will advise the coach to hire player 1 because he's more consistent in the number and how much he scores on each game. And if he tells you, why do you think he's more consistent, tell him because he has a smaller standard deviation. done.
I have a question when using the calculator.
Yes.
Because we have the two different stats that we want to put in, can we put them both in like column 1 and then column 2 at the same time?
Definitely. Let me show you how to do that. Of course you can. You don't need to delete and start doing that. So let's do an example. Let's say, guys, I give you two data sets and I ask you to find the standard deviation of both data sets. So look what you can do. I'm going to use the older calculator, older operating system. Okay, let's say we have this and we have another set right here. You put it in L2. Let me put some values. All right. First of all, before I do it, guys, can you guess what the standard deviation is going to be for L2? Look, they're very consistent. They're very close, all in the low 70s. So what do you think the standard deviation is going to be? Give me a number. I like you to start have a feel, just of it, even before computing the standard deviation.
Like one.
1.2, 2, something like that. It's going to be small, guys. You will see. So let me show you how to do the standard deviation without deleting and putting the stuff in L1 again. Look what you can do if you have this calculator. And I'll do it on the other calculator as well. You go to stat, edit, stat, calc, one variable statistic. By default, this calculator is programmed to execute L1. So if you press enter, it's going to do L1 for us. And I got the standard deviation, which is 18.7. Now we need, the standard deviation from L2. Look how you do it. You go stat, calc, one variable statistic. Well, if you guys press enter, it's just the same thing is going to happen. So you need to tell the calculator now that you are using L2. Look how do you do it. Press the second key right here and press number 2 right here. And watch, guys, see what the screen is showing you now. It's showing you that the calculator is processing L2. Enter. And look, we got 2 for the standard deviation, 1.94, which is very close to 2. How do you do it on the other calculator? Watch, guys. If you have this calculator, stat, edit, let me make sure. Okay, I'm going to put some data in L2. Just making it up. Okay, and now let's find the standard deviation. So go to stat, calc, one variable statistic. Okay, the calculator is saying I have the data in L1. Is that okay? Tell the calculator it's okay. So hit calculate. That's the first standard deviation. Let's find the second one. One variable statistic. And look, guys, you see when list L1, you need to change it to L2. So again, press the second key, then number 2, and look, it changes to L2. Now the calculator is going to do L2 for me. And here you go, you get S, which is 5.19. And that's how you find the standard deviation of 2 different data sets.